Okay, we're moving on to the last section in Chapter 6, 6.6. If anybody's confused, we did skip 6.4 and 6.5. So this will be the last of it, and we'll do a review and a test after this section. So we've been talking about areas of figures, and now we're going to talk about the area of a circle. Okay? This first part of 6.6, if you want to kind of look over this on your own, could be interesting. They kind of break a circle up into these sectors and lay them out, and it approaches a rectangle, and it's one way to kind of look at the area of a circle. But let's just get down to it here. So the area of a circle, and you know what pi is pi r squared, okay? Pi times the radius squared. Simple enough, okay? That's for the area of the entire circle, all the way around, 360 degrees, right? Okay? You probably already knew that, but now what will likely be new to you is trying to find the area of a sector, okay? The sector of a circle is just, it's basically like a slice of pie, okay? You have some central angle here, right? It starts here at the center of the circle, right? And then you have, this arc, this part of the circumference out here, all right? And we can find the areas of these sectors without a whole lot of difficulty, because the sector is just going to be some fraction of the whole circle, okay? So sector is like a slice of pie. We can find its area fairly easily, okay? So let's start out with a semicircle here, right? Now, there's 360 degrees all the way around the circle, okay? So if we have a sector that's a semicircle, okay, that's half of the circle, as you know, okay? And the angle that's formed here is 180 degrees, okay? So we have a fraction of the whole area, okay? So the sector is a fraction of the whole area. Fraction of whole area. Okay? And that's this, 180 over 360. That's our fraction of the entire area. The entire area of a circle is pi r squared. Well, a semicircle is half. Isn't 180 over 360 the fraction 1/2? Okay? So basically the area of a semicircle is 1/2 pi r squared. Well, what happens when we have, so this is 180 degrees, right? What happens when we have a sector formed by a central angle of 90 degrees? Okay? Well, what's the fraction of the total area? Well, it's 90 out of how many? 360. 90 out of 360. And you can reduce that to lowest terms and make it 1/4, okay? So this is 90 360ths of the entire area, pi r squared, right? Remember, pi r squared is the whole circle. This is the fraction of the circle for that sector. Here we have a sector with a 49-degree angle. That fraction would be 49 out of 360 times the entire pi r squared, okay? It'll give you the area of that sector. So basically, we're working out a formula for the area of a sector. Let's say the angle of our sector is x degrees, right? Or theta, right? Usually, we use theta, okay? So the formula for the area of a sector will be x, or theta, over 360 times pi r squared, the area of the whole circle. Okay? So that brings us down here. The area of any sector is just some fraction of the entire circle. How do you get that fraction? You take the angle that forms the sector, divide it by 360. And again, a lot of these you can put in lowest terms if you need to, or you can just throw them right in your calculator as is. We'll do a little bit of both as we move along. Let's look at some examples. Find the area of each circle or circle sector. Well, in this first one, it's the whole circle. Radius is 4. So area equals pi times 4 squared. 4 squared is 16, so it's 16 pi square centimeters. Okay? Now we have a sector with a 120-degree angle. Okay? So our fraction of the whole area is 120 out of 360 times pi times 9 squared. course, we can simplify that. That's 81. We can start dividing both of these by 10. We got 12 over 36 and so on and so on. And we can work that out to be 27 pi square centimeters, right, in terms of pi. In this last one, the area of our sector is 30 degrees, or the angle for our sector is 30 degrees. So our fraction is 30 out of 360 times pi times 12 squared, okay? Well, let's see, 30 out of 360, we can simplify that pretty well, right? Isn't that 3 out of 6, right? If we divide by 10, we can bring that down even more, or 3 out of 36, I'm sorry. We can reduce that even more to 1/12, right? So that's 1/12 times 12 squared, right? So one of the 12s cancels, and we just get 12 pi square centimeters. Okay? This next one we're going to disregard. It's a little too obnoxious for me. And this this fifth one here. At first glance, it looks like kind of a mess, but it appears as though we have a square in the middle. They're all congruent, okay? And then attached to the square, it looks to be 3 semicircles, okay? 3 half circles, okay? So we could find the area of each of these by just adding them up, couldn't we? Wouldn't this just be, the total area would be the area of the square plus 3 semicircles. Okay? So the semicircle area is 1/2 pi r squared, but we have 3 of them, okay? So that just ends up giving us 36 plus 13.5 pi centimeter squared. And the last one here, we have what appears to be a square, okay, a triangle, and from that we have a circular hole, okay? So all these areas together, right, would be, the total area would be the area of the square, that's easy, 10 times 10 or 10 squared, plus the area of the triangle, okay, minus the area of that circle. Okay, a little bit like a reading problem we did a while back. Okay, so we get 100 plus, what's that, 35 minus 25 pi, so 135 minus 25 pi square centimeters. Okay, on the next page, here's 3 examples for you to attempt. Okay, notice they have E's in parentheses. That's how this textbook indicates that they would like exact answers, so they'll all be in terms of pi. So pause the video now, work on these on your own, and we'll see how you do. Okay, we're back. Hope you've had a chance to work through these, or at least attempt some of them. First one should be pretty straightforward. It's a circle with a radius of 15. So our area equals pi r squared, or 15 squared. 15 squared is 225. So it's 225 pi square centimeters. Okay. The next one looks to be 3/4 of a circle, okay, or 270 degrees out of 360, okay, and our radius is 2. So the area here would be a fraction 270 out of 360 times pi times 4 squared, right, the entire circle. We can start reducing. I mean, you probably know it's 3/4, but let's go ahead and reduce this fraction to make our lives a little bit easier. So the first thing we can do is divide top and bottom by 10, right? And we get 27 over 36, right? So 27. Oh, I'm sorry, I actually wrote a 4 in there. Nothing new under the sun, right? Do that in regular class. So that's a 2. It's about to be a 4, right? So 27 over 36, I might as well just bring this 2 squared, which will be 4 right there, okay? Flip the pi, just using the commutative property of multiplication. You can do it in any order you like, so I move the 4 over, okay? So 27 over 36, that reduces even further. We can divide 27 and 36 both by 9, which is 3 times 4 over 4 pi. Now, of course, the 4's just cancel, so the area is just 3 pi centimeters squared. See, you don't need your calculator for this stuff. And in the last one, we have a semicircle and we have a rectangle. Rectangle is pretty easy to figure out. The 20 times 6, right? But the circle, well, that's 20, so that means each of these radii are 10. Okay? So a circle, that's 180 over 360, right? Or 1/2. So our area is going to equal the semicircle, 1/2 pi times 10 squared, plus the area of the rectangle, 20 times 6. Okay? So area equals 10 squared is 100, half of 100 is 50, so 50 pi plus 120 square centimeters. Okay? So we have the area of a circle, pi r squared, and for any sector, as long as you know the central angle that makes it, that's how you get your fraction of the total area, right? That, whatever the angle is, over 360 times pi r squared. So let's look at some Regents questions here. There's a handful of them. So we'll start with number 1, and I'll give you a moment to read that over and read it carefully, okay? Make sure you are aware of what they're actually asking you for. Okay? It can be easy to make a mistake with a lot of these. So pause the video on your own, read it over, see if you can set it up like some of the ones we just did and solve it. Okay, so you really need to notice that they want the area of the shaded sector, okay? You might think, well, they gave me that 120 degrees, that white sector is what I'm after. No, you've got to read, okay? So the area of the shaded sector, we're going to need to get this angle for out here. Okay, well, how do we do that? Well, 360 minus 120 equals 240 degrees. So that'll help us make our fraction, right? That's 240 degrees of angle there, 240 degrees, okay? All right, so we have a radius of 9, the angle of 240 for the shaded sector, so area equals this fraction, 240 out of 360 times pi times 9 squared. All right, we can simplify this, so area is divided by 10, right, cut the zeros off, 24, let's bring this 81 over here, over 36, pi, don't forget the pi, it stays in the whole way, okay? 24 out of 36, we can divide both of those by something and reduce it to 2/3, divide both by 12, obviously, right? So we get 2 times 81 over 3 pi, all right? 81 divided by 3, you might know that that is 27, so our area equals 2 times 27 pi, okay, which of course is 54 pi. All right, so our answer is 54 pi. Okay? Once you start simplifying these fractions more and more, they'll start to get a little simpler for you, a little less lengthy. Okay. All right, let's move on to number 2. Okay. So read that. Pause the video, read it over, and I'll be back with you. Okay, so in number 2, we're kind of doing this in reverse. They're giving you what the area of a sector is, right? And the radius of 15. So the area of the sector is 75 pi. So we'll use the formula, but we're just going to switch it around, okay? We're going to use the formula, and I'll twist the equal signs around here. We're going to use the theta over 360, right, times pi r squared equals the area of the sector, okay? Since they gave us this, I'll just put it over on the right-hand side, okay? And we need to solve for the central angle, theta, okay? Let's start plugging some things in here. So theta, start down here, over 360 times pi times 15 squared equals 75 pi, okay? Well, we're going to solve for that theta. first thing we can do is divide pi out of both sides, can't we? Divide both sides by pi, they go away, right? So 15 squared is 225. So we can rewrite this side as 225 over 360 theta equals 75. All right. So how do I undo multiplying theta by 225 over 360? Multiply both sides by the reciprocal. 360 over 225, 225 here. Same on this side, times 360 over 225, okay? Bring that, come up here. So these cancel, and we're just left with theta, and you can just push buttons on your calculator. 75 times 360 divided by 225. Yeah, 360, right? And you should get 120 degrees for that angle, which is choice 2. On to number 3. Pause the video, read that over, see what you can do. So this one's a little bit more straightforward than the last one. They gave us a diameter there of 10 centimeters, angle of the sector is 30 degrees, and I believe that is the sector they want us to find the area of, okay? But what we do need to find, though, is the radius for our formula. They gave us diameter, so hopefully you know the radius is 5. So we can just plug it in directly. So our area equals our fraction 30 out of 360 times pi times r squared. Okay, and that's 25. And we don't really have to go about simplifying because look at the form that all the answers are in. We could just put this in our calculator, right, and get one of those decimal answers. And when we do, it's 6.5 square centimeters. Okay? And that would be choice 2. So moving along. More to look at here. Number 4, pause the video. Read this over. I think you'll find it's a little bit like one we did earlier. A little bit like number 1, actually. Okay? Hopefully you've read it thoroughly, you've taken a stab at it. So they want the area of the shaded region, okay? Be careful, don't find the area of that sector where they gave you the angle. So we need the angle for the shaded region. Well, that's just 360 minus 60, which gives us 300 degrees, okay? So this is a 300-degree angle for the shaded sector, okay? Well, now we can just plug in directly. Radius is 8, angle's 300, so our area will be 300 out of 360 times pi times 8 squared. Okay, let's simplify this here, right? Cancel those 10 factors out of there. Area equals 30, 8 squared is 64 over 36 pi. 30 over 36, I believe that reduces to 5 over 6. 5 times 64 over 6 pi. Okay, and we can reduce, let's see, 36 over 6, we can make that 32 over 6, can't we? Or 32 over 3, I should say. So area will be 5 times 32 over 3, right? Divided 64 and 6 in half. Pi. Okay, and 5 times 32, it's just 160. So 160 over 3 times pi. And that matches up with choice 4. On to number 5. Pause the video, and let's see if we can set this up here. All right, this one we have to be a little bit careful with now, okay? So they gave us that the radius circles 25, and the area of the unshaded sector is 500 pi square inches, okay, the unshaded. So I'll just put that out here. Area of this sector is 500 pi. All right? And they want us to determine the state the degree measure of angle Q. So here's Q, the central angle of the shaded sector. Okay? All right, so we'll probably have to find some things and do some subtracting here, you might be guessing. Okay? What if we got the area of the entire circle and subtracted the area of this sector here that's 500 pi? That would leave us the area of that sector, right? And then we could use that to set it up and solve it like number, I believe it would be number 2, okay? Where they give us the area. So let's get the area of the entire circle, okay? So the area for the entire circle would be pi r squared, or pi times 25 squared, right, which is 625 pi. So that's the entire circle, okay? So from the entire circle, we subtract this sector area, 500 pi. That'll give us the shaded area, okay? So if we do 625 pi minus 500 pi, we get 125 pi. Okay? That's the area of this sector, 125 pi. So, all right. So now we can use the area formula for that sector and find the measure of angle Q. Okay? So angle Q out of 360 multiplied by the entire area, right, which we already know is 625 pi, right? Pi r squared, we did it right here. So 625 pi. So some fraction times 625 pi will give us 125 pi. All right, let's divide pi out of both sides first, I would say. Okay? So that leaves us then, I'll take this up over here. Well, I'll do it now. So it leaves us with 625 over 360, right, times Q equals 125. We want the Q by itself, so let's multiply both sides by 360 over 625. And this side as well, 360 over 625, right? These guys cancel, these guys cancel. Go up here, Q equals, we just put the rest of this in our calculator, and hopefully you got 72 degrees for angle Q. Okay. On to number 6. Pause the video, read this over. One thing that we have to talk about first, I guess, is maybe in one of your science classes somewhere you learned what density is. So generally, density, D, equals mass divided by volume. Maybe you remember that. Okay? But in this case, you're talking about a slightly different density, population density. It's analogous, right? But population density is just population divided by area. Divided by area. Okay? So if you read that, you see they gave you a couple of circles, and they gave you the population of bacteria in each one. I'm guessing you'll need to find the area. So take a moment and see what you can do with this one. All right, well, let's find the area for circle A, and then get the density for circle A, and then do the same thing for B over on the other side of the page. First thing we need is a radius for circle A. The diameter is 51, so that would make the radius 25.5, right? So let's get the area of circle A. So I'll do A, area sub A, so we know what we're working with, right? It's going to be pi r squared, pi times 25.5 squared, okay, which equals, going to be 2,042 point, I'll call it 821, I guess, okay? Now let's get the density for A. Density is the population of A, 40,000, over the area of the circle. So the density for A will be the population, 40,000, divided by our 2042.821, right? And that will give us a density when we push buttons, of 19.581. All right, put that in the box. All right. Let's go over and do the same thing for circle B. Let's get the area for circle B. So the area for B is going to be pi times, well, what's its radius? Half of 75 equals 37.5 millimeters, okay? So pi times 37.5 squared. So the area for B is going to be 4,417.865. Now we have the area, we can get the density with its population, right? So the density for circle B, or dish B, will be 72,000 divided by that 4,417.865, which gives it a density of about 16.297. All right. So clearly, dish A has the higher density, the greater population density. We can't just leave it like that because they said determine and state which petri dish has the greater density. So down here, we'll just simply say, erase the mess there. Just simply say, based on our calculations, dish A has the greater population density. Okay. And I believe we have one more to go. So again, pause your video, read this over. Be very careful about, say, the scale that they use on this, about a walking path. I'll be back with you in a moment. Pause your video. All right, so they want the area of this entire walking path. Here's what I've seen get a lot of kids into trouble here. They don't notice this part here. Each grid square is 10 feet, not 1, okay? Not 1 foot. So let's see if we can break this shape up into some shapes we can work with, okay? So let's take maybe this rectangle here, right? And then this rectangle separately. They look to be the same dimensions, okay? Then on the outside here, we have a semicircle from which we'll need to subtract this smaller semicircle, right? And the same over here, the big semicircle and the smaller semicircle. But I'm thinking we can treat those each as one circle, right? Because, you know, don't 2 semicircles equal 1 circle, right? So 2 semicircles equals 1 full circle. Okay? So let's treat that as 1 big circle minus 1 little circle, okay? To get the area. So let's do the area of one of the rectangles. Remember, these are each 10, right? So from here to here, 10, 20, 30, 40, 50, 60, 70, 80, 90, right? There's 90 of them, right? Times a height of 10, right? Not 1. So our area equals 90 times 10, or 900 square feet. And the other one is the same. It's going to be area here equals 900 square feet. Okay? So let's get the area of the circles then. Okay? We got a big circle and a little circle. Right? So the area of the 2 half circles, or 1, full circle, okay? First of all, we're going to need to get the radii for each, right? So for the big circle, okay, for this big circle, it looks like we have a radius of 30, right? Now for the little circle, let's go to the other side here, that's a radius of 20, okay? See what I did there? So the big circle goes all the way, the radius goes all the way up into the rectangle. Shouldn't use green there, okay? So we have 30 and 20 for the 2 radii of the circle, okay? So it's going to be the area of the big circle minus the area of the little circle, okay? So our area for the circle is going to be pi r squared 30 squared, right? Minus the smaller circle, pi times 20 squared, right? If we put that in our calculator, because they don't want, right, so they want to the nearest square foot, right? So we don't need to worry about, you know, leaving this in exact lowest terms with pi, okay? So we can put all that in our calculator, get the area of the circular part should be 1,570. 0.796 square feet, okay? So we have to add all these up then, right? So the total area, I'll go down here, our total area is going to equal the circle, 1,570.796 plus one of the rectangles, 900, plus the other rectangle, 900, okay? We add those up, you should get 3,371 square feet to the nearest foot, right? No decimals on that because it said the nearest foot. Okay. So area of the circle, area of a sector. Let me give you your problem set then. So your problem set will be number 1, 2, C and D. Number 3, we have 4, A, C, E, F, and then 5, A through E. Okay, so here's your problem set.